Okay, looking at number 1, it says, what are the sine, cosine, tangent ratios for angle B and A? I don't know why I read that backwards. Anyway, let's get started with sine A. So first thing, look at the sides that they're giving you. You are not looking for a side right now, okay? What you are looking for is a ratio to determine what the angle is. And I'm going to talk about how to find that angle once we move further. I have not yet talked about that. So if we look at angle A, let's just go ahead and mark that as theta, okay? And when I think of sine, I think so, like SOHCAHTOA, S-O-H, S for sine, O for opposite, H for hypotenuse. So the answer to this is just, can you determine what O and H are, and can you associate them properly? That will help us solve equations in the future. This is just getting you used to setting up those equations. So O and H, O and H, that would be opposite, and then H, remember, is the what? Hypotenuse, across from the 90, and that's going to be 14. So right now I have O over H, which is 7 over 14. So what I actually need to do is fix my answer to be 7 over 14 is 1/2. Okay, let's try the cosine of A. Cos is ca, so that's adjacent and hypotenuse. I think I made this a little too big. Over 2. Okay, back to cosine, adjacent over hypotenuse. That's going to be adjacent. Okay, notice we don't have that listed yet. That's the one that's touching. Adjacent is always touching, and you might think, well, why isn't this adjacent here? Well, that's, remember, the hypotenuse. So that number will go on bottom. While this 12 here, that's the adjacent side. That'll go on top. And yet again, I have a fraction that I need to reduce. 12 over 14 is going to give me 6 over 7, dividing top and bottom by 2. Let's see if you can do tangent on your own. All right, check your answer with me. Tangent is TOA, T-O-A. So that's opposite over adjacent. And opposite was already labeled 7. Adjacent was already labeled 12. There's your answer. We don't have to do anything with that one. Now, what I didn't tell you earlier is that the reference points for all of these is going to change when we change the angle. So let's erase everything we have in our triangle, but I'll leave some remnants behind to show you what it was. Okay. So in the lime green out here, this is where theta was. This is what was opposite. We figured that one out first. Hypotenuse was across from 90. And adjacent was the last one we determined. It was the one touching our angle. So if I move this angle over here to B, and we do the sine, which remember is the OH. Let's just do all these real quick. Cosine is so ka AH. TOA, TOA is T. Okay, I got my T, I need OA. OA, okay. Now I don't have to wonder about what parts I'm putting over what. Now remember, these lime green are where the values were when we were talking about angle A. Now that we're talking about angle B, if we do O over H, O is opposite, and if you look, it's the old adjacent value. Because the angle moved, so did the opposite side. So now the new opposite side is 12, and then hypotenuse, that actually never changes because 90 degree didn't change. And we can reduce this to 6/7. Notice these are now the same answer. If I look at the cosine of B, that's going to be the AH, which is going to be the adjacent side, touching right here. It's the old A over H, which is still 14, and that's 1/2. Notice these are now the same answer. Let's see what happens on this last one. O has been labeled as 12. A has been labeled as 7. You'll notice these two answers are very similar. They're not the same, but they are reciprocals of one another. Alright, so now that you kind of get the gist of how to figure out what these ratios are, let's see how we can solve these.